In this video, we're going to review how to name ionic compounds containing multivalent elements. So the rules for naming these type of compounds are very similar to rules to naming any other type of ionic compound. It's just that you really have to indicate which multivalent element version you're dealing with. Like, are you dealing with iron 2 or iron 3, copper 1 or copper 2? It's not a problem for other types of ionic compounds because there's only one version of the ion. So for example, if I had NaCl, there's only one sodium ion there, or one type of sodium ion. It's the Na+1. So I don't really have to indicate that. I can just say sodium chloride. And you would know if you have a multivalent element or not by looking at your reference tables that you're provided. So the problem would arise when you have something like this. So let's say I have FeCl2. Now for this one, iron could be Fe+2 or Fe+3. So when I'm naming it, I have to make sure I know which one I'm dealing with, and I have to indicate that. So for example, if I'm naming this as iron chloride, that's not 100% correct because I don't know which version of the iron I have in there. So I have to put in brackets which iron I have. Is it +2 or +3? And that's really the only additional layer to naming these type of ionic compounds, is recognizing you have a multivalent element and then figuring out which version of it you have in the compound. And then just make sure you put that in the name. That's the only difference. So to do this, to find out which version I have, I usually do what's called a reverse crisscross. So let me show you the work. I have Fe. I'm going to put the 1 back there because I know there's a 1, Cl2. And I'm just going to rewind the crisscross. This will go back up to where chlorine was, and this will go back up to where it was on iron. And that will be Fe+2. That's because the metals have plus, and then -1 because the nonmetals have negative. So this shows me that I have iron 2. So I can put that as a Roman numeral, iron 2 chloride, as opposed to iron 3 chloride. The other thing I just verified before I move on is, was this the correct charge of the nonmetal? Chlorine is in group 17, wants to gain 1, so -1. We'll see why that's important later, but I always do that before I move on. We'll try another example, FeCl3. I'm sure you probably know what this is by now because of what we did above, but let's try it anyways. So same idea, we're going to write down that it's iron brackets chloride because we have to indicate which iron we're dealing with. We don't know which one it is right now. We know that iron is a multivalent element from our data tables. We have to figure out, is it the +2 or the +3? So you can do the reverse crisscross. So Fe1, Cl3, reverse crisscross it, bring them back to the opposite sides and on top. And that gives us Fe+3 plus because it's a metal, Cl-1 minus because it's a nonmetal. And so this is iron 3, 1, 2, 3, chloride. And I always check the chlorine there to make sure it's this right charge. Chlorine's group 17, needs 1 more electron, -1, we're good. So that is how you would go ahead to name a compound that's ionic containing a multivalent element. Let's see some cases where it can sometimes be a little bit trickier to figure it out. But it's still the same process, you just have to be a bit more careful. So here I have CuO. First of all, recognize that Cu would be in your reference table as one of those multivalent elements. It can have more than one charge. It could actually have a charge of either Cu+1 or Cu+2. So I know this is going to be copper something oxide. So what we're going to do is we're going to do the reverse crisscross to find out which copper we have. Cu1O1. Now bring that back up here, this back up here, and you get Cu+1 O-1. And if you stop here and you don't double check your negative ion that you should normally double check, you're going to mistakenly say this is copper 1. This is actually not copper 1. It looks like it right now, but look at this carefully. Oxygen from the periodic table is always going to be -2 because it's in group 16. It should be O-2. We have O minus 1 here. And the reason for that is, remember, when you do ionic compounds, you reduce. So you have to check what the original ion was before reducing. If oxygen was normally -2 and now it's -1, that means we did -2 divided by 2. That means we divided everything by 2. So we need to do the opposite of that, which is undivide by 2. So we're going to multiply everything by 2 here, and we'll get Cu plus 2O minus 2. Now the oxygen has a correct charge, and we know and we're confident that we have copper 2, not copper 1. So that's copper 2 oxide. Let's take a look at another example. Cu2O. So we have copper something oxide. Now it's tempting to put 2 because there's a 2 there, but remember, that's not what that means. That 2 means there's 2 of the copper ions. We need to figure out what are the charges of those copper ions. So we have to do a reverse crisscross. Cu2O1, bring this up here, bring this up here, and we get Cu plus 1, because that's a metal, O minus 2. Notice the O minus 2 is good. That means this compound was not reduced, so we can be confident that this is copper 1 oxide. Copper 1 oxide. Now we'll do an example with a multivalent, with a polyatomic ion in there. And you'll see that it's essentially the same thing. Just be careful with your polyatomic ion. Don't modify it. So here we have, let's do FeNO3, 3. So we know iron can be +2 or +3. So what we're going to do here is we're going to write down that it's iron something. This is NO3, which is nitrate. Nitrate. We're going to do the reverse crisscross. So we're going to put our 1 back there. NO3 was 3 over here. We're going to grab this, put this outside the bracket there, and this, put this over here. And we get Fe plus 3, NO3 minus 1. If you look in your reference table, you'll see NO3 actually does have a charge of -1. This was not reduced. So that means that this is actually iron 3 nitrate. We can be confident in that. Let's try another example. We'll do FeCO3. Be careful here. When you're doing this, again, remember, iron can be either 3 or 2. So we have to put iron bracket something. This is carbonate. Carbonate. So when I do the reverse crisscross with my polyatomic ions, if there's no bracket there, put the bracket back. You have to make sure you're putting the 1 back there because it's still there. We just don't see it. If you didn't do that and you move the 3 up by accident, you'd make a mistake. You'd change your entire polyatomic ion. So just protect that polyatomic ion. Put the bracket back. We have a 1 there and a 1 there. So that gives us Fe plus 1, CO3 minus 1. We know from experience, from our practice already, that Fe can be either +2 or +3. So something is wrong here. We have +1. Look at carbonate. In your reference table, it should be -2, not -1. That means it was divided by 2 in the reduction, so we have to unreduce by multiplying everything by 2, and that gives us Fe plus 2, CO3 minus 2. And so now our charge here is correct, so that means this is actually +2, not +1. We will do one more. Let's do AuPO3. So first of all, recognize we have gold, which is a multivalent element. We have PO3, which is phosphite. So gold is multivalent. We don't know its charge yet. We have to put brackets. PO3, we go to a reference table and we see it's phosphite, ITE. So let's do a reverse crisscross. So AU, that should be a lowercase u. Let's erase that to make that look like a lowercase u. We'll put a 1 there, and then put your polyatomic ion in brackets. Like this. And we get AU plus 1, PO3 minus 1. You might think this is gold 1, but be careful. Always ask, is my negative ion the correct charge? It's not. It should be minus 3. So that means this was reduced by dividing by 3. So undivide by 3, multiply by 3. And you'll get your correct charges here of AU plus 3 and then PO3 minus 3. This is now correct, so we know this is gold 3 phosphite. Let's do one final one. You can try this yourself and then check your answer. So we have SnO2. So this is one where students make a lot of mistakes. This is Sn. Sn is tin. Tin can have more than one charge, so I know I'm putting brackets there. And oxygen is simply oxide. We have to do the reverse crisscross. So SN1, O2, bring this back up here, bring this back here, and you get Sn plus 2, plus because it's a metal, O minus 1, minus because it's a nonmetal. And a lot of students would simply put tin 2 oxide. And this would be incorrect because remember, check your nonmetal charge to see if it's right or wrong. O minus 1 is wrong. O should be minus 2 based on the periodic table. Why is this minus 1? Well, the whole thing was reduced by dividing by 2, so unreduced by multiplying by 2. And you get Sn plus 4, O minus 2. Now your oxygen's good, and now you can be confident that you have the right charge for the tin 4 oxide.